more proper way would be to look at each block individually, and after all they do ask about the tension as well. So what I would write down here is that for block 1 the tension is important, and of course these two check marks were for the weight and the normal force anyway, so I don't need them. So tension 1 equals mass 1 times acceleration of that block, and this one is negative, so this one here will also come out to be negative, which makes sense because the block is moving to the left. And then for block 2 what we have is the tension that is up. Here tension is up and weight is down, so this one here will be negative, and that equals the mass of the block times acceleration. Now we don't know the tension here, but from the way it's indicated it probably comes out to be less than the weight, so we're going to have a negative overall on the left hand side, which also will give us a negative acceleration. Now here we have a couple of unknowns, and here we also have a couple of unknowns. What do? Well, we're using Newton's third law that says that the two tensions here are equal and opposite, so I have T1 equals T2 because the two are the same, but remember that T1 is to the left, negative, T2 is up, so it's positive, so in order to reconcile the two I need to put a negative in front of it, and of course that is justified by Newton's third law, which says that force 1 equals negative of force 2. That negative naturally appears in Newton's third law, that's not invented. So these two here, so I'm going to have m1 times acceleration equals negative m2 times acceleration. I just noticed that I forgot a 2 down here. There we go, there's a 2. m2 times acceleration minus weight 2, and then if I had a little bit more space, I'll move everything down. Then now I can solve for acceleration, and what I will come up with is that I have a plus w, so negative negative, but the w itself is still a negative, divide by m1 plus m2, and of course that's the same thing that I had earlier with the quicker way, but I needed to do it properly because I said I would be very consistent so that you can see, hey, I just didn't make up this quick way here, but this is really where I came up with it. Okay, of course for the tension itself then, once I got this one here, I can figure out what the tension is. For example, tension 1 equals mass 1 times acceleration. Actually, I don't have to write that down again. I just do it up here. Mass 1 times acceleration, I just calculated, come up with an answer, and that will be negative as well because the tension 1 points in the negative direction, with the acceleration being negative as well, as I calculated here. For tension 2 plus weight 1, well, here I actually do have to write it down. So tension 2 equals mass 2 times acceleration minus the weight 2. I come up with something. Now here we have the mass times negative acceleration, and then this is minus a negative, so that will be added, and then you will see that you will come up with a plus positive sign, which would make sense that this tension you're pointing up should be positive. Now, why did I turn it around, the whole scenario here? Well, as far as explaining the forces with Newton's third law, that possibly could have worked out. I still have here the tension and here the tension, T1 and T2, and the other forces would have worked out as well, and my explanation would have, well, it's actually the pulley pointing in this direction with its components and so on, and then the table pushing back on the pulley, so we have all these reaction forces. Anyway, what would have not worked out is, notice that tension 1 here points to the right, so it's positive, and tension 2 is pointing up, so it's positive, and I could not have reconciled that right away, where I say, okay, according to Newton's third law, tension 1 equals the negative of tension 2, because it's not going to work. Both of them in this case here are positive, but one of them needs to be negative in the opposite direction in order for this one to be correct, for Newton's third law to be correct. So I had to pay attention to that this here is not going to work for being very consistent. Overall here, the quick way would have still worked. But my consistent one, I ran into a trouble of all of a sudden coming up with, well, this one is also going to be a positive acceleration, but this one here going down is a negative acceleration, and I couldn't reconcile the two. So that's why I turned the whole thing around, so that now this tension vector becomes negative, and now for the upper case, what I showed there, this one here would work out, this being negative and this being positive here. That whole equation is correct, Newton's third law. So I really couldn't get around it. I had to turn it around in order to stick with my being consistent in plugging in positive and negative numbers correctly, and in this case obeying Newton's third law.